Welcome to GE Power Systems Generator Production Company, based in Building 273 in Schenectady, New York. Over the course of a year, we build approximately 100 generators for commercial, military, and utility applications. We supply generators for steam, gas, and combined cycle applications. Our customers expect very reliable generators that meet rated output over a 20 to 30-year life. Because our product operates under very high electrical stresses, it is very important that we all pay close attention to the problems that can damage the insulation systems and degrade our product's reliability. The purpose of this video is to provide an overview of generator manufacturing processes, highlight the critical quality characteristics, and their impact on our product's performance. Because the long-term performance of our product depends on attention to detail by all of us, please pay close attention to those areas which you can directly help to control. If you have additional questions, please contact your manager or area quality representative. The generator manufacturing process begins with stator assembly. The stator is a large welded frame in which thousands of silicon steel laminations are stacked to form the first element of the stator core. The silicon steel laminations are punched from thin stock at our Knott Street plant. Extreme emphasis is placed on dimensional accuracy through tight die control, removal of burrs via sanding processes, and coating with an insulating enamel to assure the punchings are electrically separated from each other. Electrical separation is critical to prevent magnetic flux from overheating the core in operation. The laminations must be carefully aligned and checked to assure that stator bars will fit accurately into the slot and maintain specified clearances. After the core is fully stacked, it is torqued to assure core tightness and vibration characteristics meet design criteria. The stator bars are manufactured here in 273, strand by strand. This complex operation requires a high level of quality awareness. Bars are transposed, that is, strands are rotated along the length of the bar to assure even heating during operation. Strand shorts can occur in the transposition area if it's not correctly insulated. Every strand in the bar is tested for strand-to-strand shorts as a routine part of the fabrication process. Shorts between strands cause local hot spots in the bar during operation. Each stator bar then is shaped to a specified cone angle on a bar form. The shape is critical to the nesting of bars during assembly. Before taping, the bar must be inspected for burrs or high spots. Our tape is a mica epoxy mix that provides insulation of the bars from the stator core. Each layer of tape is half-lapped over the previous layer and applied the entire length of the bar. Through the entire fabrication process, the stator bars must be handled carefully to prevent damaging of the insulation system by tearing, puncturing, or scraping. After taping, bars are secured into the loading rack to maintain their formed shape through the compounding process where the taped insulation system hardens or cures. After insulation curing, the stator bars are cleaned, inspected, high-potted, and moved to the stator wind area for assembly into the stator frame. Inspection and cleaning the stator core must be the first steps in the stator assembly process. Extreme care is required as you insert the bars into the stator core because impact damage to the insulation or excessive flexing of the bar may cause high pot failure. We locate the stator bar by the axial support system. The binding bands, located on the diameter of the winding, support the bar arm. Use the pin gauge to locate the center line of the bar perpendicular to the slot for top bar alignment. While the pin gauge is locating the position of the nose of the bar, clamp the bar down to achieve at least 50% compression into the felt on the binding bands. Secure the bar firmly to the binding bands with glass roving to prevent movement during operation. Here we can see that proper bar shape is critical for tight nesting of the bars. When all the bottom bars are secured to the binding bands, the bars are tested at a specified voltage for insulation damage that may have occurred during assembly. Resistance temperature detectors, or RTDs, are strategically located in the stator winding to detect temperature variations while the unit is in service. This provides the customer with a means to determine whether his unit is running above or below design temperature criteria. The top bars are assembled in the same fashion with careful attention to handling, compression into the felt, and tying. The top bar must align with the bottom bar without excessive force so that the insulation is not damaged and the bars align for the brazing operation. When the entire top bar installation is completed, each top bar is also high-pot tested at a specified voltage. During the wedge assembly, we are careful not to damage the insulation of the stator bar. The bar must be tightly wedged into the slot to endure the bar forces and vibration it will see in service. Other salient operations in the stator assembly process include brazing, connection ring assembly including blocking and tying, and insulating the phase connection and series loops. The completed stator is moved into the oven to bake and cure the insulating materials and high-potted for the last time before final assembly. The field is the other half of the generator assembly process. After non-destructive tests are complete, each rough field forging is machined on a lathe, then slotted. Each slot must be carefully cut to the correct angle relative to the pole face and to the correct depth and width. When the machining processes are completed, including dovetails and shrink fit areas, we chip the forging to remove all sharp edges. This is done in the deburring area where sharp edges are blended to establish a radius. Sharp edges and burrs will inevitably cause high-pot failures by cutting the insulation during assembly or operation. When deburring is complete, the field goes to the wind shop. Each coil that is assembled into the field in the wind shop is fabricated by craftsmen here in 273. A field unit may have from 10 to 20 coils. Each coil is made up of continuous copper turns ranging from 7 to 48 turns per coil, depending on the electrical design. There are several critical quality characteristics to consider during coil fabrication, including the braze quality, which is critical to the integrity and strength of the coil. Misaligned vent holes can cause the field to run hot, resulting in uneven field cooling. This causes expansion and ultimately bowing of the field body. Also, the vent holes must be carefully cleaned, deburred, and all sharp edges removed to prevent insulation damage. We clean the turns to remove all burrs, sharp edges, and high spots of braze alloy in the gusset area. Failure to remove these deformities can result in punctures of the turn-to-turn insulation. The next step is to carefully assemble slot insulation and coils into the machined field forging. The objective is to insulate the copper turns from the forging body. If this insulation is damaged during the assembly process, high potential electrical energy can pass from the copper coil to the forging, thus causing a high-pot failure. As the turns are assembled into the forging, each turn must be insulated from the other to prevent shorts in the winding, which degrades machine efficiency. It's critically important to align the punched holes in the insulation with the vent holes machined in the copper turn. Misalignment of the vents or anything that results in obstruction of proper ventilation can create hot spots and result in thermal vibration problems when the unit is in service. We complete the insulating process by butting, overlapping, and trimming the slot and end strap insulation. This process requires careful attention to detail to assure all copper areas are covered. With the coil assembly completed, the creepage blocks and wedges must be installed and carefully aligned to maintain an open and free-flowing ventilation system. When the unit is in service, the copper coils will heat up and expand. We support the coil end straps with carefully fitted fiberglass blocks. Block locations are determined from the center line of the pole face and must be precisely located to drawing specifications to assure an evenly blocked field, thereby reducing the possibility of a thermal vibration problem. The end windings are protected with several layers of Nomex and glass to insulate them from the retaining rings. Machined from 1818 chrome steel alloy, the retaining ring holds the end winding assembly together when the field is turning at rated speed. It is installed on the end windings by heating it to very high temperature and shrinking it onto the field as it cools. Upon successful testing, we assemble the field and stator and add the necessary parts and support systems to enable the unit to work at a customer site. These systems include bearings, pedestal and end shield, piping for oil and cooling systems, wiring for control and feedback systems, and assembly of bases, cabs, and enclosures. The tests performed at final assembly include leak check of piping and tests of the wiring to assure compatibility with customer specifications. During the final assembly process, it is critical to assure that the stator does not become contaminated with metallic filings which can damage stator insulation during operation. After completion of the final assembly process, the generator is painted and shipped to the customer's site. Once on site and in operation, our generators are expected to last 20 to 30 years with minimal maintenance. Because our product is electrical in nature, we must all pay close attention to the factors that impact the reliability of insulation systems in every step of the generator manufacturing process. To meet our customers' expectations, it is critical that our processes be controlled, drawing requirements are followed, and appropriate inspection toll gates are implemented. Only through attention to details will we continue to make a GE generator the natural choice for our customers.